Hello again. Now let's move to part 2. Question 12. Treadmills may be used in a gym to increase the difficulty of the training. The gradient of the treadmill can be increased. A person on a treadmill warm up by running at a constant speed. So we have a constant speed with the treadmill horizontal. He then sets the treadmill to an angle of 3. We have an angle 3 to the horizontal and continue to run at the same speed. Calculate the additional power that his leg would have to supply when running for 10 minutes with the treadmill at this angle. So first you have to understand, he asks about the extra power needed to move up for this angle 3. Okay. This angle. So first we have to know what is the distance moved, to know what is the height, and of course the power equal energy over time. And in this case we have two types of energy, in fact, kinetic energy and gravitational potential energy due to increasing in height. But in fact we can't use kinetic energy because he needs the extra power needed. So he talk about the increase in gravitational potential energy. So the first step, you have to find distance. So distance moved, because he's moving with a constant speed, so it will be this speed multiply time. So speed is 2.5 multiply time is 10 minutes. You have to convert 2 minutes to seconds, multiply 60. So distance moved equal 1,500 meter. Now this is the distance, 1,500 meter. Now the next step, to find the height. The height will equal distance moved sine angle, because height is the opposite for the angle and the hypotenuse is what? The distance. So it will be 1,500 multiply sine 3. So it will give you 78.5 meter. Now let's move to find the gravitational potential energy, which is M multiply G multiply height. M is 80 multiply 9.81 multiply height, which is 78.5. Now use your calculator. It will give you 61,606.8 joule. Now the final step, to find the power. Power equal energy over time. So energy is 61,606.8 over time is 10 minutes. Multiply 60 to become in second. So the final answer will be 102.7, which can be rounded to 103 watt. The next part B, suggest why running on treadmill is easier than running on a running track. Of course, we have many reasons. I will choose the easiest one because there is no air resistance. So it will be, there is no air resistance. Let's move to the next. A train moves between two stations. A simplified velocity time graph for the motion of the train is shown. So first you have to be sure you have velocity meter per second and also time in second. Now you don't need to convert any quantity. Draw a corresponding acceleration time graph. So we have a speed time graph and he wants acceleration time graph for the motion of the train. Show all working in the space below, and it has a 6 marks. So I will draw here. First we have to know the acceleration. We have three types of acceleration in part 1 and part 2 and part 3. Okay, so first I will find acceleration for part 1, which should start from 0 until when? Until here. So it's until here. So what is the time here? The time is 40. So I will find acceleration from 0 to 40 equal v minus u over t. So what is v? V is here, is 27. So it will be 27 minus 0 over 40 equal what? Use your calculator. It's equal 0.68. 675, it will be rounded to 0.68 meter second minus 1. In part 2, acceleration starts from 40 to 300. So now we are talking about acceleration in part 2. It's from here, sorry. So it starts from 40 to 300. As you see, we have a constant velocity, zero acceleration, because we don't have a gradient for this line, so it will be 0. Finally, we have to find A from 300 to 360, because it's the length of the deceleration here, so this is 360. It will be also v minus u over t, so it will be 0 because the final speed is 0 minus the initial speed, which is 27 also, over the different time is 360 minus 300. So it will give you about negative 0.45. Sorry, this is unit meter second minus 2, not minus 1. Okay, now the next step, again, I have to draw now. To draw, you have to choose a suitable scale, so I start with 0. Now we have 0, it will be 0.4, 0.8, okay, and by the down it will be negative 0.4, negative 0.8. Okay, now we will choose for the first 40 seconds. First 40 seconds, it's 0.68. So it's now here 0.6, 6, 2, 4, 8. Okay, now each time we will increase by 0.04. So this will be, you have to understand how you can find the accuracy for each one. 0.4 minus 0 divided by 10 equals 0.04. The accuracy is 0.04. So this is 0.4, 0.44, 48, 0.52. Until now we have 0.6. We need to draw 68. So 64, 68 will be here. So I have to draw a straight line here. Okay, now let's move down. So this is the first acceleration. Then we have 0 acceleration until 300. So now we have, this is the 0 acceleration. Okay, finally we have to draw 0.45. So 0.45 will be here 44. So this will be here 45. Okay, here. Until 360. So this is how to draw the velocity time graph. and of course you have to delete this one. Okay, so this is the final answer. Let's move to the next. Now he said, while the train is moving at a constant speed, a passenger threw a ball horizontally. So now, as you see, the ball starts moving because it's in the train, so it's moving in this direction. Now we threw the ball from the window, so we have a vertical velocity and horizontal velocity, so the resultant velocity will be in this direction as he drew for you. Okay, the path of the ball when viewed from above is shown in figure 2. Any effect of the air resistance can be ignored. Okay, so again this is ux and uy, or vx and vy. Okay, horizontal and vertical. Explains the shape of the path. So you can write the ball is affected by a horizontal velocity in the direction, in the train direction, and a vertical velocity in the direction of through. So it will move with the direction of the resultant velocity. This is the resultant velocity. Let's move to the next. Now he said, the path from the ball when viewed from the side is shown in figure 3. The effect of air resistance has been ignored. Explain the shape of this path. Now as you see, the ball will move down. So we have two types of motion, horizontal and vertical. And as you know, there is no air resistance. It means there is no horizontal force. So when I explain the shape, it will I will say it moves with constant horizontal velocity. It means zero acceleration and an increasing vertical velocity due to acceleration of free fall. This is why the path takes this shape. Now he said figure 2 and 3 are shown again below. Add to this figure the path of the ball if the effect of air resistance is not ignored. So if we have air resistance, in this case it will fall with a lower velocity and lower displacement. So it will look like this. Okay, and in the first one figure, because the air resistance will decrease the horizontal and the vertical also, so the resultant will be less, smaller. This is why we will draw like this. Let's move to the next. In 1865, in his book From the Earth to the Moon, the writer Jules Verne wrote about sending men to the moon. In order to escape the Earth's gravitational field purposed firing the capsule from a cannon of length 220 meters. So this is the distance as shown in illustrating from the book. So now he will start from 0, moving 220 meters. The velocity of capsule by the end, velocity equal 11 kilometer second minus 1. Calculate the acceleration. He asked you to find the acceleration. So we will start with converting v from kilometer per second to meter per second. So it will be 11 multiply 1000 equal 11,000 meter second minus 1. Then to find acceleration we have distance, so we will use v squared equal u squared plus 2as. V squared is an 11,000 squared equal u is 0 because start from rest, plus 2 multiply acceleration multiply 220. So now we have 11,000 squared equal 440 acceleration. To find acceleration, you just divide 11,000 squared over 440. So the answer will be 275,000. So it will be 275,000 meters second minus 2. It can be assumed that only 50% of the energy supplied by the gunpowder in the cannon would have been transferred to capsule. So we have 50% of energy from gunpowder transferred to what? Transferred to capsule. And what is the type of energy to capsule? It's kinetic energy of capsule. Okay, determine the mass of the gunpowder that would have been required for maximum velocity, speed 11 km per second. Mass of capsule is given and energy released per kilogram is given. So first you have to know what is the energy from gunpowder. The total energy input from gunpowder is 2 kinetic energy because 50% of it is changed to kinetic. So if you multiply kinetic energy multiply 2, you can gain the total energy from the gunpowder. And of course the 50% is lost due to the friction force, resistance, like this. Okay, so now let's find 2 multiply kinetic energy half multiply mass multiply v squared. So it will be half multiply what is mass 1500 multiply v squared 11,000 squared, and don't forget to multiply by 2 because we said 2 kinetic energy. So it equal what? It equal 1.815 multiply 10 power 11 joule. Now he gave me energy released 3 megajoule per kilogram. If you want to find the mass, you have to divide the energy input 1.815 multiply 10 power 11 over the mass per unit, the energy per unit mass. 3 mega, it means the 3 multiply 10 power 6. It will give you the mass needed like this. For example, 1 kilogram will give us 3 megajoule. So how many kilograms will give me 1.815 multiply 10 power 11 cross multiplication? This is why I divide this over 3. So the final answer is 6.05 multiply 10 power 4 kilogram. It can be rounded to 6.1 multiplied 10 power 4 kilogram. Let's move to the next. In order to land safely on the surface of the moon, Verne suggested that gases could be ejected from the capsule to reduce its speed. Explain how ejecting gases from the capsule could reduce its speed. Your answer should include a resultant reference to Newton's first and second law. So first he said the capsule push the gas downward, so by Newton third law, the gas will push the capsule with an upward force equal size and opposite direction. Okay, now we have finished Newton's third law. Now, as the capsule affected by two forces, weight downward and the force from gas upward, resultant force upward, so it will make the capsule decelerate by Newton second law. Okay, next, so I will see you in part 3. Now we have finished part 2.